Hello, everyone. Welcome. Thank you for choosing to spend your time with us today. Today's webinar will cover how to incorporate wolfSSH into your Yocto builds, presented by software developer Jacob Barthelmeh. My name's Kristen, and I will be moderating the webinar. All attendees will be in listen-only mode. If you have questions, please use the Q&A box. After the presentation, Jacob will answer your questions. As always, our webinars are recorded and made available on our YouTube channel. If you'd like to stay updated with the latest from wolfSSL, follow us on Twitter, connect with us on LinkedIn, and subscribe to our YouTube channel. Feel free to contact us via email at facts@wolfssl.com if you have any questions. Before we dive into the technical presentation, I'd like to provide a brief overview of wolfSSL. Today, wolfSSL secures over 2.5 billion connections. We have more than 2,500 OEM customers and dozens of resellers. wolfSSL consists of over 50 dedicated employees, primarily engineers. This progress is, of course, supported by a strong partner network that we're proud of. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO-178 support, FIPS 140-3 certification, and a FIPS Ready offering, MQTT up to the V5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfboot, Java wrappers and JSSC support, and commercial support for curl, and our newest product offering, wolfHSM. These offerings are accompanied by a thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. Now I'd like to turn it over to Jacob to discuss how to incorporate wolfSSH into your Yocto builds.
Thanks, Kristen. A brief overview of what we'll be covering today is history and Yocto support with wolfSSH, how to build wolfSSH, and going into adding it to your existing Yocto builds, using alternative configurations than the default one with wolfSSH, and running wolfSSH applications at the end. And then at the very end, we'll leave it open for questions and answers, Q&A. So what is wolfSSH to begin with? wolfSSH is a lightweight and embeddable SSH protocol implementation covering RFCs. It's built for embedded devices, so its minimum footprint size is of around 33 kilobytes. It's relatively light as far as how much memory it needs to use and the code footprint size. And it's designed to use wolfCrypt for the cryptography primitives. This leverages all of the best tested cryptography that's available in wolfCrypt, along with the FIPS 140-3 certification available that can be used with the wolfCrypt in conjunction with wolfSSH. It's not tied to any specific threading model. It's very portable, wolfSSH is, and even can be used on devices that are running on like a bare metal or even without an OS. It offers password and public key authentication. In addition to that, it also has support for X509 authentication. A little bit about wolfSSH's history. We started back in 2014 with wolfSSH. That was when the first commit was made up on our GitHub repository, the initial commit. It was initially developed for replacing like a serial port or a telnet socket on an embedded device for logging and configuration. And then it expanded out to have client support in the library around 2017. And the year after that, we added SFTP, SCP implementations, TCP, IP forwarding. In 2018, near the end of that year, it also saw the Yocto recipe added to our meta wolfSSL repository. And then in 2020, we did the addition of the SSH agent support. Then the last couple of years have seen quite a bit of expansion as well with wolfSSHD, which is the daemon. We added support for that, support for post-quantum algorithms, and also interoperability testing that has been done with the post-quantum support. And then we bundled in a client application last year in 2023. Before diving a little bit more into wolfSSH's use with Yocto, covers a little bit about what is Yocto. Um, as most of you know, Yocto is a project used to easily create customizable Linux builds. It's an open source collaboration with the main components of it being BitBake, which is used to build the packages, and then Open Embedded Core, which hosts a lot of the packages and recipes, and then Layers, which is used to point your project to where you want your packages to come from. And it's easy to build for targeting different architectures. That's one of the places where Yocto really shines. Say you're building for the same kind of setup for multiple different architectures, one for an ARM, one for x86. It's easy to have the same list of packages and then just target the different devices with it. And a lot of times it is used with embedded devices. That's one of the things that Yocto is mainly used for is the Linux builds with embedded devices. So wolfSSH's Yocto recipe is located up on our Meta wolfSSL GitHub repository. That's the link here, the github.com wolfSSL meta-wolfSSL. And this actually holds all of our Yocto recipes. So there is some of the open source ports that we've done in other locations on that repository, and then there's the main wolfSSL. There's also like a wolfclue, our command line utility, wolfTPM, MQTT, and there's a subfolder under the recipes-wolfSSL that is named wolfSSH, and in that you have the um, the bitbake file for wolfSSH, the BB file. Without building inside of Yocto, the typical way that you build wolfSSH is with either AutoTools or an IDE. When using AutoTools, you would do something like the autogen.sh, configure and make to get the default build, and then make install if you so desire to put the library at the like user local lib location for other applications to link with. The other common way to build a wolfSSH is with IDEs. This is going to be things such as Visual Studio on Windows. We have a lot of example projects in our wolfSSH /IDE directory that can be used with a lot of the IDEs and environments that we've ported wolfSSH to. And it leverages the user underscore settings.h for the configuration, what features are going to be enabled, and how wolfSSH is configured. And this follows the same type of pattern as what people would expect from wolfSSL as well. When building wolfSSL for an IDE, it also follows the same type of setup of pulling in a user underscore settings.h for the macro defines for the configuration. When moving on to like a Yocto build with wolfSSH, which is also doing like the auto tools kind of build behind the scenes. The first steps you would do is to source the pokey/OE init build environment, which would set up a build directory for you. And then this is going off of like a very basic build. You could do the image underscore install underscore append, adding that to your local.cnf file, the local configuration, and then to the conf bblayers.conf, you'd want to add the location to meta wolfSSL, which you can see on the bottom here. that was appended to the BB layers available. And then after doing that, it's as simple as doing bit bake wolfSSH to get the default wolfSSH build. If adding to an existing setup, so you're not just creating a fresh Yocto build and you already have some BB layer conf file already set up, you could just adjust the existing conf local.conf file to in the project to have the image install append. Could also do wolfSSL and wolfSSH for installing both of them. And we support older versions of Yocto as well as the newer versions of Yocto. So Yocto had a slightly different syntax with their newer versions versus the older, and that's just what this shows here is the newer versions have the semicolon there, and the older versions the underscore. But our recipes for all of our recipes for wolfSSL, wolfSSH will handle either kind of syntax. The previous example was just for the default configuration of wolfSSH. That is the library itself. It doesn't have any of the applications when it's built for the default. So no SSHD, no client, no port forwarding. Yeah, it's just the bare SSH implementation to allow a SSH connection. Not even support for like the drop down into the shell like you'd expect with a lot of different SSH libraries, just the trimmed down version so that it can fit on embedded devices, be used for simple things like a debugging connection or passing a file across or something along those lines. To add more configurations, you can add a wolfSSH underscore %sign.bb append. And what that'll do is basically all of the configurations that you can put in there with the extra OE conf. When it's building wolfSSH, it'll add those options to the auto tool configure command that it runs behind the scenes. So in this extra underscore OE conf here, we added enable SSHD, enable shell, SFTP, SSH client. If you'd like to throw in just basically all of the features that wolfSSH has, there's also enable all that can be used. And this is at this moment all of the configuration options that we have. There's ways to disable the examples. We got keygen, SCP. And you can see all of these either in our wolfSSH manual or we have nice helpful little comments next to them if you run the ./configure -h. They'll print off all of the options available. The only thing to keep in mind is when building wolfSSHD, it also depends on virtual crypt. A lot of that is going to be for like the passwords, checking a password when a user is connecting. So inside of that BB append file mentioned earlier, you'd also want to put the depends on virtual /crypt. And when most SSH daemons are running, they have a user that they're running as. One option is to set up an SSHD user. This would be an example, a basic example of setting up the SSHD user when creating the Yocto build. The other option that wolfSSH has is to be able to set the macro wolfSSH underscore SSHD underscore user to the particular user you'd like to have the daemon running as. Some people could set that as a heightened permission user or potentially root. It's very configurable for what you would like the SSH daemon user to be. So after building wolfSSH, then you go on to making use of the library or the applications that are built are bundled with wolfSSH. The wolfSSH library itself will be located in user/lib, and it can be linked to by any applications running on the Yocto build after it's started up. The include files is also in the default location user/include with Yocto builds. And if built with enable SSHD or enable SSH client, the resulting applications will be located in user/bin. And this is all assuming that the -- prefix option is the default. Um, as with any auto tool builds, you can add -- prefix if you'd like to have it installed in a different location. For actually getting uh, the build set up and ready for something like QEMU and actually turning it on and testing it, we would run something equivalent to this bitbake core-image-minimal. Basically, what that's going to do is build a very small minimal Linux build. And since it has the image install append of wolfSSH and wolfSSL, it'll build those by default and put it into the root file system when it does that core image minimal build. Next couple of things to do in preparation for actually starting up a QEMU system and testing out the wolfSSH applications would be to run bitbake meta-ide-support after that core minimal image finishes successfully. Then Yocto has a couple of actually run QEMU commands here. The first one you see there is the run QEMU extract SDK. Basically, that's going to be setting up the file system locally. After the bitbake core image has built successfully, you have this temp deploy images folder with the default QMUX 86-64. Obviously, you can target different architectures here, but this is the one that it defaults to, so the quickest to show here. And then core image minimal QMU 86-64-r.bz2. So basically, this is extracting the root file system to be just in QEMU-root. Where it's extracting it to is arbitrary. I like to use QEMU-root, but that can be any directory that you'd like it to be extracted to. And then with run QEMU, it also has this QEMU-boot.conf file. I prefer doing no graphics, especially with these core image minimal builds. And then you specify the location where you extracted the root file system to as the last argument. That starts it up, and this is an example of what it would look like after you log in. The default login with the Yocto builds is root, just root with no password. Obviously, that can be configurable. That would be outside of the wolfSSH build, though. That would be more like how you're setting up your Yocto build itself. But we can show wolfSSHD-v showing it successfully. Runs the application after booting up in QEMU. And then this is kind of an example of how you could start it up in the background. So you'd run wolfSSHD with your typical SSHD config file. And it's meant to be a drop-in replacement for OpenSSHD. So the SSHD_config.txt here could have all of the same type of configurations that you would normally see in an OpenSSH SSHD_config file. And this is just a screenshot of it running locally with QEMU. Like I mentioned, the defaults for login. In this one, I ran it in the foreground. We set up all of our flags to be the familiar type of flags that if you're used to running like OpenSSH's SSHD. So it's the familiar flags of -D for foreground, -T for debug. And likewise, there's the wolfSSH client. If enabled with enable-SSH client, that gets installed to user bin. And we also set that up to be the familiar type of patterns that people are used to with OpenSSH. So it can there's no learning curve for picking up our applications. Yeah, and that covers where the recipes are located at up on our meta-wolfSSL repository, and how simple it can be to just add it to the BB layers file and run a bitbake wolfSSH and have it incorporated into your build. At this time, I'll open it up for if there's any questions.
Thank you, Jacob. If anybody wants to ask any questions, we've got a couple here. Go ahead and type them in the Q&A box. You can also raise your hand if you'd like to answer it live, or excuse me, ask it live. Here's the first question is, does wolfSSH provide support for hardware security modules, HSMs, or secure key storage supported in Yocto?
Yeah, it's a good question. How to safely store your keys is a big concern, especially in security. We make use of wolfcrypt, but we don't have all of the pieces tied in yet for using like a HSM with through wolfcrypt, that is, when wolfSSH is calling down to wolfcrypt. So that would be a nice feature to have and something that we've got on our radar, but not yet incorporated. No.
Okay, thanks, Jacob. Next question, can Yocto builds be verified with Docker containers?
I'm not sure on the answer on that. I know we do have like a lot of Docker builds, at least in our wolfSSL repository, but yeah, I'd have to get back to you on the answer to that. We could we could answer it through like our support channel if you contacted us at support@wolfSSL.com or fax@wolfSSL.com. That I could get back to you on that one.
Great, we'll follow up with that post webinar. Another question, how should keys be securely generated and stored in your Yocto build systems for wolfSSH?
Yeah, so we provide a couple of example keys. Um, it it it's really a little bit outside of wolfSSH where the keys are going to be generated. A lot of people like to, at least if their system is accessible externally, like to have the keys in a pretty secure area. That's going back to like the HSM or the TPM. Um, yeah, that would be just a little bit outside of like the wolfSSH build for the key management side of it for generation, that is. We would basically be just used for like generating example keys, at least the code that's in the wolfSSH, that is.
Okay, thank you. Another question here. Does it work in a build that also has OpenSSH installed?
Yeah, right now there's not any collisions with OpenSSH since we don't have the auto startup on port 22. Um, so you can build it in builds that also have OpenSSH running. And then you'd have the wolfSSH library installed and be able to link applications against wolfSSH, even if you have OpenSSH also running on the system.
Okay, great. There's one other question, but it's it's regarding licensing. So we'll go ahead and answer that one offline. If there aren't any more technical questions, Jacob, thank you for hosting the webinar, and thanks to everyone for joining. You'll be mailed a copy of the webinar recording and PDF slides, and you can keep up with our upcoming events, meet our team in person, read our blog posts, and get the latest wolfSSL updates by following us on X, connecting with us on LinkedIn, and subscribing to our YouTube channel. If you have any questions at all, please don't hesitate to shoot us an email at facts@wolfSSL.com. We're here to help. Thanks again, and look forward to seeing you again.